All right, questions? I'm doing well, thanks. Yeah.
So for the lab thing,
Yeah.
what was the signature sheet?
Oh, there's no signature sheet for the first one because there's nothing to demonstrate.
Okay.
So you're just turning in a report. It's kind of a hello world for labs. So.
But what will that be in the future then?
Oh,
I remember you saying something on the first day, but I don't think we're recording it on either side.
so if you look at like lab 2, at the very bottom there's a sign off. And just fill that in, right, and then get somebody in there to look at your code and behavior and, you know, show them that the light turns on and off in response, have them sign the witness line and so on, and then just put a copy of that in your report.
Okay.
And if you do this on a Friday, I'll be in there, or if you catch me during office hours, you can say, hey, can you come look at this? But if there's anybody else working in there, they can do this, and it tells them what to expect, so they don't have to know what the lab's supposed to do other than that. Other questions?
Just digital turn this for the lab.
Just what?
Just on canvas, turn it on canvas or the PDF.
Yes. Yeah. All right, any issues with ODPs? So I posted a note on Canvas because I've had a few people who have sent me emails saying, I think the ODPs are broken because my code works, but it gave me 0 out of 10. And I can't really do much with that, right? I can look at the logs and kind of tell what your code looks like, but if you want help through email debugging stuff, it really helps if I can know as much as possible about what you're doing and what happened. So my suggestion, and I posted this in an announcement, is do a few things. Show me what directory you're in, show me what the date is, do a PS-full user followed by your username to show me what processes you have running. Except my name's Nick, right? And then show me your code, so cat, haha.java, whatever your code is, and then show me what's happening that's causing a problem. If you're trying to run your program and it's giving you an error, run your program and let it give you that error. If there's a problem with assess, you're saying something like this, and it's giving you some message or whatever. And then when you're done with that, if you're doing this through PuTTY, just go ahead and grab all of that text and then paste it into an email message and send it to me, along with whatever it is that you're wanting to say to me. And that gives me a lot to go on. Okay, then we can have a meaningful conversation about, I tried to assess this and the code works fine, but it gave me 0 out of 10. And I can look at it and say, oh, but you used, the wrong syntax for the assess or whatever. Right? Does that make sense? What you don't want to do is take screenshots and send me 25 screenshots that I have to paste together in my mind, or put things into a zip file and tar them and then encrypt them and then send them by carrier pigeon, because it takes me a long time to reverse all of that and so on. So this is the most direct way I found to be able to look at this, ideally on my phone if I'm not at home, and say, oh, okay, let's take a look at this. So just something to keep in mind. All right, so we talked about accessors and mutators yesterday, and ODP 302, the third one, is about adding an accessor and a mutator to your My class. So that should work, and a few people have already turned that in, so it looks like the code's working fine. And that'll do it for ODPs for this week, okay? I might post one Monday morning, that'll be due Tuesday, but I won't post any over the weekend. Okay, so we're set for now.
I guess I might as well ask.
Okay.
Is the class going to be the same as last quarter tomorrow?
Yeah, at least for now. my plan is that Friday is going to be, instead of coming up here and lecturing on new material, it's going to be a chance to come in, work on things, ask questions, have discussions, whatever, just to try to keep the two sections in sync. That may change over time, but I'll obviously let you know if that's going to change. But if you haven't gotten Eclipse installed yet, I would say try installing Eclipse before tomorrow. And if you're having trouble and you're doing this on a laptop, bring it in and we can work on that. If you're having trouble with the labs, we can work on that, obviously. Or whatever else you feel like doing during that time period. Did you get the pizza form turned in?
Yeah,
So we have pizza tomorrow?
we should.
Come to club meeting tomorrow. All right, there should be pizza.
There's a couple of other administrative things that I have to work on since I wasn't on the club card or something. So
Okay.
my signature technically doesn't mean anything.
Okay.
So I have to go do that today because I got that email yesterday.
Mhm.
So.
Okay, cool.
But we should have pizza tomorrow.
Yeah, sounds good. All right, well, let's talk about PA1. So PA1 is about fractions. You're going to create effectively a new variable type for Java, which we're going to call a fraction, uppercase F. This is basically a way to work with rational numbers. So we have integers, we have real numbers, but there's nothing inherent in Java for working with fractions. And fractions are useful sometimes, right? If you're doing accounting, it's nice to be able to have 1/100th of a dollar. And if you try to do this as 0.01, that's not exact in standard floating point format. There's some rounding error. And so if you're doing billions of dollars worth of operations and you have tiny little rounding errors, those errors can add up, right? So the office space ATM thing. So fractions are nice, and some languages support decimal representation, fixed point notation. So we're going to make a fraction class. And I want you to start by thinking about abstract data types. So suppose that you were working in a language and you were told this language supports fractions, right? So fraction is just, some integer divided by another integer. So those are both integers, and the denominator is usually not 0. So what sorts of things would you like to be able to do with fractions?
Adding them would be nice.
Okay, so we'd like to be able to add, and while we're at it, subtract, and multiply and divide. So we want to do arithmetic on fractions.
Oh, do you want us to print it?
Printing would be good.
You want us to simplify them? or-
Yeah, simplify.
Simplify.
You
Right,
want
so
them to
if you
be-
do 5/1 times 1/5, you'd hope that you'd get 1/1 instead of 5/5. Right?
Or just one.
Or just 1.
So should we be able to convert it into just a normal integer at that point?
Let's convert to a double.
Okay.
So that if you have 1/2, we get 0.5 instead of 0. So convert to a double. Anything else?
Would you want to work with mixed numbers also, or just?
Like 4.5?
Yeah.
That could be handy. I'm not going to ask you to do that, but yeah, that would be a useful one too. Maybe I'll add that. No.
Being able to convert into a fraction.
Okay,
Double one, maybe if you can, making it into a fraction.
that would be cool. I'm not going to ask you to do that, but
You can do that with different constructors.
Well, I mean, you can do any fraction as 0.5 would be 5 tenths. And then
Yeah, but you
like
can't
that.
convert every double into a fraction just because some doubles will be irrational.
Yeah.
So there's
Actually,
that.
they're all gonna be rational because
Or they
it's
would
a fixed
eventually, yeah.
number of bits. But that would
It's
be
not an infinite
interesting.
number, yeah.
Yeah.
And it's like, converting it to double might be more trouble than converting doubles to fractions, because you have stuff like a third.
That's true. So converting to an exact double is not always going to be possible, but we can get close. So yeah, double the fraction would be cool. I'm not going to ask you to do that one, or the mixed fraction.
Oh, the mixed number there is just multiplying that integer, which you can convert into a fraction,
Yeah,
and then multiplying that by the actual fraction next to it. So
Yeah.
there's that.
reciprocal.
Oh, yeah, that's true. Like, jumping and stuff.
And I won't ask you to do that, but we can see a pretty easy way to do that. It's kind of obvious, which I think is why it's interesting. We want to be able to construct fractions, right? We want to be able to give a fraction an initial value.
That's true.
So set f equal to 1/3 or whatever. So this is what you're going to be after for PA1. Okay, creating fractions, doing arithmetic on them, something to help print or output them, some simplification and conversion to a double. And the next thing I want you to think about is abstract data types. If this is what you as a programmer want to do with fractions, ideally those are the only things that you can do with fractions. For example, how are you going to store your fractions internally? Well, you're probably going to store the numerator and the denominator. Are you going to store those as integers, as floats, as doubles, as strings? It's up to you. You could do any of those. Now, it would be a little weird to store them as strings, but there's nothing wrong with that. And it might make printing easier in some way, right? But we don't want the user to have to worry about how you're storing these fractions internally. So we're going to use information hiding. We're going to have pieces of our class that are private. For example, the numerator and the denominator are going to be private. And so the user won't be able to come in artificially and say, okay, I'm just going to change this field in my fraction class to be a 5. So we're going to have two other things we want to be able to do. We want to get the numerator, and we want to be able to get the denominator. That's not strictly necessary, but it's handy. If you have a fraction that's 5/7, it might be useful to be able to say, hey, the numerator's 5, the denominator's 7, to find that out from your fraction. All right, so let's look at the actual assignment. All right, so you're making a new class. It's called fraction. It's got to be called fraction. If you call it something else, none of my code will work with it. So, name of the class is important. And I'm going to ask you to give me two ways to construct a fraction. One way is to just pass a numerator and a denominator. So I can say, make me a fraction which is 5/7. So I'll construct with a 5 and a 7. But sometimes we're going to want to construct fractions that are actually whole numbers. So if I want a fraction that's equal to 3, I could construct with a 3 and a 1, but give me another constructor that just takes the numerator. Right, so I can construct fraction 3, and it's 3/1. All right, and then 4 methods for doing arithmetic. Add, subtract, multiply, and divide. And the examples here are showing you how you might do these operations. So suppose we have some fractions. A and B. and we've given them some values. So in other languages, we could just say A times B, and we could get this star to call our code. Java doesn't let you do that. But what we can do is we can say A is a fraction, it has a multiply method, and we give it one argument, which is the thing we want to multiply by. So this should be legal syntax. Okay. So this is saying take A, run its multiply method with an argument of B that should multiply A and B, which gives you a new fraction, and set C equal to that new fraction. So it's a little different from how we're used to writing arithmetic expressions, although if you've ever done something like Lisp, this will start to feel familiar. So that's how we multiply, subtract, add, divide. Bless you. So in the description here, I'm assuming that that x is a fraction, and this just shows how you would add, subtract, multiply, and divide x and n. So 4 methods for doing arithmetic, and then a method for converting to a double, and I want you to call it 2 double. And 2 double doesn't need an argument. Okay, we don't say 2 double parentheses f. We say f dot 2 double, and that automatically converts the fraction f into a double and returns that double value. Okay, and this is really important, right? The temptation may be to write a function that takes a fraction, returns a double. That's not what you want to do. Okay, that's a C mindset. This is an object-oriented mindset. So x dot 2 double will convert x into a double and return the value. Okay, a pair of accessors, get num and get denom, return the numerator and denominator as integers. And then a toString method. So we talked about toString briefly, right? So when you call toString, it should return a string which somehow represents the object, in this case the fraction. And there's wordage in here to describe what toString would return, but let me give you an idea of what we're after. So suppose your fraction is a half. You'd like toString to return 1/2. If your fraction is -1/2, you'd like it to return -1/2. If your fraction was 1/-2, we'd still like it to return -1/2. Okay, so make it look reasonable. Make it look like how you would hope somebody would write one of these fractions. Lowest term, so 2/4, should come out as 1/2. If you happen to store this as a -1/-2, that should just print as 1/2, or not print, but convert to 1/2. And if your number is something like 5/1, that should convert to just a 5. Okay, so the things that seem reasonable, and the assignment spells out all the nuances, but if you print something like, -5/-1, that's not a reasonable looking representation of 5, right? So just some sanity checking. All right, you'll probably want a method which will be private called reduce. You're not going to ask the user to call reduce. Our assumption is fractions are always reduced. They're always in simplest form. Yeah?
If someone creates the fraction, should we immediately reduce it?
That's the best strategy.
Okay.
If you keep everything reduced internally, it minimizes your headaches. If you only reduce when you output or something like that, you can get into trouble. So yeah, as soon as a fraction is constructed, go ahead and reduce it. That's my suggestion. And reducing means a few things. It means finding the greatest common factor and dividing it out. But it also means, for example, dealing with the minus signs. So if you have a -4 and a -2, find the greatest common factor is 2, that becomes -2/-1. If you have two minuses, get rid of both of them. If you have only one minus, put it on the numerator, would be my suggestion. And I'm not going to take off points if you do these things differently and the final output is correct. Okay, so these are just suggestions. But reduced form, I would say no common factor. If either the top or the bottom is negative, put it on the top. Right, if both are negative, get rid of both of them. And we'll talk about division by 0 in a second. But I'm going to suggest that if you have something which is divided by 0, store it as 1 over 0. Set the numerator to 1, the denominator to 0. And when you're finding GCD, remember the GCD algorithm works best with positive numbers. So if you're trying to find the GCD of negative 35 and 14, right, find the GCD of 35 and 14, and then make the top thing, right, divide both of these by the GCD, and this will be negative, that'll be positive. And do you remember the GCD algorithm? So 35 equals 2 times 14 plus 7. 14 equals 2 times 7 plus 0. That's the GCD. And pretty clearly you can exercise your GCD code without worrying about classes or fractions or toStrings or anything else, right? That's a whole little standalone project. And it's not a bad sort of get your feet more wet with Java and the compiler and so on. Just make a reduce method and call it with a bunch of arguments and make sure that it works, debug it. And you can do that before you do anything else, or you can do it towards the end, but it's kind of a separate task, right? It doesn't get intertwined in all these other details. And that'll be a private method if you decide to make one. All right, the other weird detail is division by 0. So with fractions, if the denominator is 0, it's considered undefined. Java will actually return infinity if you do something like 1 divided by 0. But for us, anything with a denominator of 0, we're just going to say it's undefined. And it doesn't cause an error. You don't want to blow up. You don't want to print an error message. But we want to remember that this fraction has an undefined value. So if at some point you encounter a fraction that has a 0 on the bottom, right? Could be positive, could be negative, could be something like that, could be 0 over 0. You want to do something to let your code know that this fraction is what we call undefined. And anytime you add, subtract, multiply, or divide involving an undefined number, the result is undefined. So it's a special case. And if you don't treat that as a special case, for example, if you take 14 over 0 times 0 over 14, your code might say, oh, this should just be 1 because they're reciprocals, okay? That's the wrong answer. If you do 1 divided by 0 times 0, your code might say, oh, multiply by 0, the answer is 0. That's the wrong answer, okay? Undefined operated with anything gives you undefined. And you can store the fact that this is undefined in a few different ways. You could put a flag in your class that's perfectly legal that just says this fraction's undefined. Or you can decide that whenever I have an undefined, I'm going to set the numerator to 1, the denominator to 0, and you can check for that. It's up to you. There's other ways you can do it. The important thing is if you operate with an undefined number, the result is undefined. Doesn't matter what the operation is or the other operand. Just come back with undefined. Okay, any operation involving an undefined results in an undefined. The only time that this is going to come up to the user, though, is when you convert to a double or when you try to convert to a string. Right? Because if you have a fraction that's undefined, you've set your flag or something like that, that's transparent to the user. Right? They don't see a message just because they tried to divide by 0. But if you convert to a double or you convert to a string, the fact that it's undefined is going to come into play. So when you convert to a double, you want to return this double.nan. Okay, double with an uppercase D, period, NAN, uppercase N's. That's an actual thing. It's a field in the double class. and it's a value that you can assign to a double variable. So two doubles should return that if you're trying to convert an undefined number. And the toString method should return 3 characters NaN if you try to convert an undefined number to a string. Does that make sense? The undefineds trip people up, and it's usually from overthinking it. Okay? As soon as you divide by 0, your undefined operations with that are undefined. If you print it, print NaN. If you convert to a double, return double.nan. That's really all the special cases. All right, printing, we talked about this, so cleaning up. So if it's divided by 1, don't print the /1. Keep the minus sign in front, not on the bottom. And undefined should print NaN, should return NaN. And toString doesn't print anything, right? It just returns a string. But if you try to take a fraction and concatenate it to a string with a plus sign, the system will call the toString method to convert that fraction to a string and then concatenate that to whatever's before the plus sign. But it doesn't print anything by itself. You'll only get output if you actually say print this fraction. All right, so grading, really straightforward rubric here. 100 points for this assignment. If the code works perfectly, you get 90 points for the behavioral part. Okay? If it mostly works, but there's a few errors, a few glitches, but the basic, the arithmetic operations work and so on, but there's an edge case here or there that's not working, you'll get 70 points. If some of the functions are working, but you can't divide, or your addition doesn't work or something like that, 50 points. If most of it's not working, but you've got, a constructor and the basic mechanisms, but most of the details are wrong, I'll give you 30 points, and if nothing's really usable, you get 0 points. Okay, so that's the breakdown for the behavioral part, that's 90 points. Documentation is 10 points. Okay, so I want to see somewhere in your code the following: your name, the class, the date, a description of the assignment. What does this class do? The fraction class, not 223. Right? So what's the fraction class about? Okay, just a synopsis. And then every method, I want some kind of documentation on it. If you want to do Java doc, which we haven't gone over yet, that's perfect. Okay, but it can be just as simple as, the add method takes a fraction, adds it to this fraction, and returns the new fraction in reduced form. But the idea is, if you were to hand this class to somebody else, they can look at these comments and understand what this package does, this class. Okay, so I want to see the header block. I want to see documentation in the beginning of each method. And I want you to comment non-obvious lines in your code. Okay? So if you say x equals minus x, you don't need to say, / convert x to its negative. That's not a useful comment. If you say denom equals minus denom / we only want to use GCD on positive numbers, that's a useful comment. Okay, to me at least. Why the heck am I converting this thing to its negative value? Right? There's a reason you put that statement in there. If it's not glaringly obvious, just put a comment on it. All right, so documentation, if you got all of that, you get 10 points. If you got the header block, but not a whole lot of comments, in spots where they really should be, you'll get 7 points. If you have really just the header block, you get 3 points, and if you're missing the header blocks, you get 0 points. Does that make sense? Okay. So I have some sample code in here. Don't fall in love with the sample program. Okay? This is a set of code that I will use to test your class along with maybe some other things. But this is not sacred. Okay? You want to test this with your own code. And I recommend writing your own code to test this as you're developing it. But when everything is done, you're signed off on it, I'm finished, I'm never gonna look at this again, right? You can run it against this code and see if it works correctly on these. And this has some basic stuff and it has some edge case testing. But let's just look at how you might use this. So this is a class called fraction test. It's got a main program in it. And I set a equal to the fraction 1/2 and b equal to the fraction 4. So I'm testing both types of constructors. And c, d, and e are fractions. They haven't been given values yet. So here I'm saying let's make a new fraction, which is 125/50. And I'm concatenating that to this string 5/2:. And I'm expecting this to print 5/2:, and then it should print 5/2. Because if I convert the fraction 125/50 to a string, it should be 5/2, right? And notice what we're doing here. We did not assign this new fraction to a variable and then print it out. I just said construct a new fraction and concatenate it to this string. Perfectly legal, very encouraged. Okay, we don't need everything to go in a variable just so that we can use it.
So when you do that, it automatically pulls the toString function?
When it sees the plus sign, so the first thing that'll happen is it will call the constructor for fraction with these two arguments. That'll return a fraction, and so this new fraction, parentheses, basically gets replaced by a fraction. And now it says here's a string concatenated with a fraction, and it'll say, okay, let's call the toString method in that fraction. It gets that string and now concatenates that with the first string. And then it feeds all that as an argument to print line. Okay, here we're saying c equals a added to b. So we're taking a, calling its add method, giving it an argument of b. So c should be equal to 1/2 plus 4, should be 9/2. Did we need to say c equals new fraction in this code?
It's implied, right?
Yeah, I mean c is a fraction. When we just say fraction c, we haven't given it a value yet. But that's exactly what we're doing in this bottom line. We're giving c a value. There's no need to construct a new fraction and set c equal to it. Unless that's what we want to do. For a, for example, we wanted to create a new fraction 1/2 and set a equal to that. That's why we said a equals new fraction. But c, we're not trying to construct a fraction with a particular numerator and denominator. We're trying to take a, add b, and we want c to be equal that, so it's just c equals a add b. And this is the same thing we talked about in C, where I said don't do the following. So I'll put this in red. Right? And if I saw this on people's code, I always flagged it out and said, don't do this. Because this is saying temp is a pointer to a node. This is saying have temp point to this location in memory. And then you say have temp point to that location in memory. Right? This was superfluous. And in C, it actually gives you a memory leak. So exactly the same idea here. If we were to say c equals new fraction and then say c equals a add b, that new fraction is now abandoned, right? It's garbage, and eventually it'll get garbage collected. But it's superfluous. Okay, so what's going on here? I said new fraction 1, 2, that creates a fraction which is equal to 1/2. As soon as we have a fraction, it has a multiply method. So I said, let's call the multiply method. And it needs an argument, which is a fraction. And for the argument, I said new fraction 2, which constructs another fraction, passes that to the argument of the multiply method of this object, which is a fraction. And that whole thing should be 1/2 times 2 should be 1. Since I'm concatenating, it calls the toString method of this fraction. and it should end up with just the character 1. And we're doing this again without any temporary variables. Okay, so this looks pretty different from what we might do in something like C, but it should make sense if you kind of relax your mind around it. Okay, if you try to force the syntax, it's like, but where is this stored and where is that stored? But if you just kind of like let it flow, right? This new fraction 1/2 is a fraction. It's got a multiply method, it needs a fraction as an argument. Here's a fraction, that's the argument. So this whole thing between new and the semicolon is basically a fraction. Does that make sense? And this is fun to work with this stuff, because you can just start going crazy and it's like really, really efficient. All right, so the way I wrote this test code, right, this is going to, for example, this line right here, system out print line, it's going to print 1: space, and then it will print whatever all of this returns from its toString method, and it should return just a 1. So you should see 1: space 1. This should print 9/2: space, and then C, and C should be 9/2, so it should print 9/2. So if this works correctly, right, the thing after the colon should look like the thing before the colon. So, but if it doesn't, check the code, because there might be typos in here. So A minus B, print that out. B minus A, print that out. Make sure that you've got the sense correct. Right, B sub says I want to subtract from B. Okay, so B sub A is doing B minus A. A sub B is doing A minus B. Multiply is just multiply. And here I'm taking C and multiplying it by itself. That should work fine. Again, if we think about it too deeply, it might seem really weird or wrong to pass this object as an argument to a method that's part of the object. But there's nothing wrong with that. And then I make a pair of fractions, 3 and 4, and then I divide D by E, and that should give me 3/4. And on and on and on. And then there's some test code with doing some 2 doubles. So make the fraction 1/3, convert to a double, and concatenate that. I should get 0 point a bunch of 3's. Here's a fraction 1/0, and when I convert that, I should get not a number. And here's A, which is 1/0. When I convert that to a double, I should get nan, and 0/0 should do the same thing, and minus 1/0 should do the same. So those are just some test cases. So submission, all you need in here is a single class, fraction.java. Okay? If you feel like you needed to make other classes, that's fine. Take all your classes, your .java files, put them in a tar file, upload that to Canvas. Is that all clear? Okay, so let's talk about ways to approach this first of all, and then we'll refresh on how we operate on fractions. Suggestion: make a constructor. Okay, and if you want, just start off with the constructor that takes 2 arguments. The one that takes 1 argument is even simpler, but just make a constructor. It takes 2 integers, saves numerator and denominator. Okay, and then make your get numerator and get denominator, so that you can read back the numerator and denominator. Or start off and don't make those private. Leave them public so you can print them from your main code. It's up to you. And work on your multiply routine. Okay, multiplication is the most straightforward of the 4 methods. And now just write a test program. Make a fraction equal to 1/2. Make another fraction equal to 5/3. Multiply them. Save the result in a fraction. Print out the numerator and denominator. And see if it's doing the right thing. Okay, if you get that much working, you're almost done. Okay, because you've got all the mechanisms in place, the structure of the program is done at that point. So getting to that point means, figuring out how you make a class and what's uppercase and where are the curly brackets and where are the semicolons and how do you compile and all of those details. Okay, but if you can construct, multiply, get the top and bottom and see what they look like, then you've got all that structural stuff done. And now you're just writing code, okay, which you know how to do. You've been doing this for a long time. So at that point, right, do a get numerator, get denominator, make the top and bottom private, make sure that works fine. Pretty straightforward to write divide, add and subtract take a little bit more work, but it's work the computer's going to do, not you. And then work on the two-string. That would be my next suggestion. And two strings, one line of code, right? You basically want to form a fraction. And forget about the details. If it's -2/-4, don't worry about it, right? This is just, you're developing it. So, but it gets you to the point where you can say something like print line, quote, f equals, close quote, plus f. And it'll show you f equals -4/-2. And that's good stuff. Right? So you're giving yourself little rewards as you're working on this. And when you can print this out with a print line statement, that's a nice little reward there, right? It feels good. And then start worrying about the details, right? Clean up the minuses so that it's not minus/minus. And I wouldn't worry about reducing, I wouldn't worry about division by 0 until the very end. Right, so get this stuff working. 2-double is a line of code. An extra line when you worry about division by 0. But how do you convert from a fraction to a double? Just take your numerator, convert it to a double, take your denominator, convert to a double, divide them, and return that. And how do you convert to a double? You just cast. All right, again, not worrying about the denominator being 0. And then you got all that working, right? Now you can either work with division by 0 or work with the reducing. And like I say, when you're ready to reduce, you can do that sort of as a separate task. And then once you have a way to reduce into commonest form, lowest form, as Taylor said, if you do that every time you construct, you never have to worry about it again. Okay, I've seen submissions where people, every time that they add two numbers, they have 10 lines of code to do Euclid's algorithm. And in their subtract method, they have 10 lines of code to do their Euclid's algorithm. And in their two-string method, and so on and so forth, right? You can make it really hard on yourself, but if you always keep it in reduced form, meaning no common factor, minus sign in the front, et cetera, then every time you construct, you're good to go. So one of the other weird details when you write your first method like multiply is you need to return a fraction, right? So how do we multiply two fractions? Let's suppose we have a over b and we want to multiply by c over d. Well, we know that's just ac over bd. And we want to return a fraction that looks like this. That'll work.
Feels like cheating almost.
I know, it does, isn't it? It's cool. Right, so that's the numerator and denominator I want, make a fraction and return it. And this is what we wanted to do in C, but we couldn't, so we were doing pointers and all this kind of stuff, right? So that's why I say this stuff is fun once you've got the structure down in place.
And why it's generally more used than C.
Yeah. Well, it gives you code that is in many ways easier to read and easier to work with and easier to maintain. And I have a lot more fun usually writing Java than I do writing C. I don't know, something about it just feels good. All right, so quick refresher on fractions. All right, that's how we add two fractions. And we're finding a common denominator. It's not the least common denominator, but if we're going to call a reduced function, that'll take care of it for us. So we can just put this in the numerator, put this in the denominator. And if you subtract, it's exactly the same. Just subtract. And if you multiply, and if you divide, just multiply by the reciprocal. And that's as complex as it gets.
So if we get radicals, do we have to simplify that as well? Like if we get 1 over root of 2, we could turn that into root 2 over 2.
So we're constructing with integers, so you won't have that problem.
Constructing with other fractions.
Yeah.
That comes to recursive.
But you could
Impossible.
do fractions of doubles, I suppose, and that would be interesting. But we can start getting into a lot of theory of mathematics if we go down that road.
Do you want to finish it on?
Yeah.
Are we gonna get numbers so big that non-reduced it doesn't fit in integers, but reduced it does?
Yes, that's possible. So here's a classic example. 1/2 times 2 over 1. Right? I should be able to do this a trillion times and not blow up your code. I won't do that. I haven't done that in the past, but I always threaten to. Right? So if you're not reducing until you output, for example, this would keep being, 2 over 2, 4 over 4, 8 over 8, and so on, and it would eventually blow up. So yeah, you want to reduce every time that you operate, so you avoid that.
It wouldn't be hard to do on your part.
It would take a while, though.
Think like a loop.
Yeah, but it would take a while to run, I think.
Oh, okay.
But yeah, maybe I'll do it this time. But I won't give you like ridiculous numbers that actually do blow up, so.
Okay, I was gonna ask about that because you can
Yeah.
do like 1 over the maximum
So-
integer.
Yeah, so don't worry about that, right? I could take like biggest integer times biggest integer, and that's my bad. So as long as you can multiply the integers in Java, you're okay multiplying the fractions. I won't do anything nasty.
Let me check that 1 divided by infinity just to be 0. Well,
Say again?
Well, 1 over infinity would approach 0, yeah.
Yeah.
Or like,
But if I did big number over 1 times big number over 1, you'd get like overflow over 1. Right? That's okay. Don't worry about trying to catch that. All right, cool. So come by tomorrow if you want to work on Eclipse or labs or anything like that, or you have any questions you want to talk about. Otherwise, I'll just be in here hanging out and we can go over whatever.